session for your circuit theory. So a little bit about myself. So my name is Rahul De. I have completed my masters from IIT Hyderabad in control system. My gate rank is All India rank 108 in 2014, and I have also given gate in your 2020. That time my rank was AIR 96. So I have been teaching with IGC from the last 2.5 years. Okay. So I take circuit theory. I am also taking your core INE subjects, digital electronics, control system also. So let us then begin today's session. We are going to see few things of circuit theory. So circuit theory means how many, let me ask you this thing. How many of you are from electrical, EC and INE? So you can respond in the chat or you can just tell it to me so that I will be getting a knowledge. EC. Okay. So most of you guys must be from EC or electrical. So that is okay. That's okay. Yeah, electrical also. Okay, fine. So these are the syllabus for your EC as well as for IN. Okay. So let me first ask you guys, means like electronics and communication and electrical engineers. Okay. So what are you guys basically doing? What do you mean by EC as well as electrical? So what is the basic thing that is happening in your engineering stream? So anyone want to say something? See, basically electrical or EC. Okay, so I will be discussing the syllabus. Let me just tell a little bit about this. So EC or electrical, basically the quantity that you are dealing with, it will be what? It will be electricity. Okay, so either you want to transmit, okay, either you want to transmit or you want to transfer, okay, electrical energy. Like electrical engineers, they are basically going to transfer, okay, you are going to transfer electrical energy from one form to another form. Okay, and electronics and communication, you guys are basically more concerned about how to transmit electrical energy, or you can say electromagnetic waves. Okay, so this topic in which we are going to study, this is going to be what? This is going to be related to your lumped parameters. So any electrical quantities or characteristics, it can be either lumped quantity or it can be distributed quantity. So this topic, this whole subject, circuit theory, it is based on your lumped assumption of all the circuit elements like resistance, capacitance, inductance. In your EMFT chapter, you are going to see about the distributed characteristics or distributed parameters. Okay, so you can see the syllabus for your double E in electrical circuit. It is what? So network element. So these are very simple. Like your network elements, we are going to see resistance, capacitance, inductance. We are going to see all those things. We are going to study your KVL, KCL, all the important laws. Okay, how we basically convert current source to voltage source and vice versa. We are going to see all those things. Then we have your network solution method. So these are basically what? Network theorem. Okay, network theorems like your Thevenin theorems, Norton theorem, superposition theorem, all those things we are going to see. So basically what happens, it actually helps us in solving complex circuit. Okay, so then we are going to have what? Transient response. Okay, so transient response we are going to see. And then complex circuit, means complex circuit. In complex circuit, we are going to supply your AC voltage source or AC input up till this point. Okay, up to this point, we are going to have all your DC input and we are going to talk about DC circuits. From this point onward, we are going to talk about your AC circuit. So for electrical, these topics are very, very important. Okay. So previously, these topics were not asked that much, but nowadays, like from 4 5 years, they are actually asking lot of questions from this part. Okay. Next we have what? Next we have for electronics and communication. So you can see the syllabus is little bit less if you see over here, but actually it is same. Okay, it is same, just that here it is compressed. and here it is, you can see it is written in a vague manner. Okay, so here also the syllabus is same, there is no change from the above. Last we have for instrumentation. So for instrumentation also, only different topic that you have is realization of basic filter with RLC elements. This topic you are going to also study in your signal and system. So if anyone is from instrumentation, they have to study this extra topic, that is your basic filter. So same topic, it will be studied by even electronics and communication and your electrical guys in your signal and system. Okay, so now talking about books and resources. So anyone have anything to ask in this topic in your syllabus part? Okay. So now talking about books and resources. So as Dinesh sir told, we usually provide the e-materials, and in that we are going to also have your previous year questions and all those things. On top of that means your class notes. I will be helping you with that. Okay. So I always prefer that you make your own notes rather than copying from someone else or means getting something from your internet. Okay, so I will always say it is better to make your own notes. Okay, so class notes, it will be adequate for your this gate syllabus. Gate part, it will be adequate. Even for engineering services, it will be very much adequate, your class notes. But if you want to practice, okay, means you might be requiring questions for practicing also. So I will suggest that once I finish one topic, like if we finish two port network, okay, if we finish two port network, I will say immediately first solve the previous year questions of EC, electrical, IN. So irrespective of from whichever branch you are, whether you are from electrical or you are from IN or you are from EC, it doesn't matter. For your common subjects like this network theory, then your signal systems, analog electronics, digital electronics, control system, I will suggest that you solve all the previous year question of the three branches. Okay, so that is far enough than solving more questions from different sources. Okay, because I will show you in today's session only, I will show you the importance of previous year questions, that how basically you won't be finding any question exactly copied. Okay, but your concept is going to be the same in different questions. So that is why I stress a lot on your previous year questions, that you should be solving all the previous year questions of ECE, EE and IN for common subjects. But still, if you want to study means from different book, and means my notes, all the notes I have actually prepared it from two standard textbooks, so I will be also writing the name of those textbooks. So the first is Fundamental of Electric Circuit by Alexander Sadiku. So this is one very standard book, and lot of questions, okay, lot of questions, they are similar to gate. Okay, so this book is the best book. Language is also very simple. Okay, and you will even find the real life application or the real life practical examples of whatever thing you study in this book. And second book that I will be suggesting, it is your Engineering Circuit Analysis, okay, by your Hat. Okay, so Matthew Hat, full name. But this book is also very good. So you will find a lot of concept of this book in this book, because this is one of the old book to follow. But the language in this book, it is a little bit tough compared to this book. Okay, so this is one old book, like your 1980s, this was the first time published. Even this professor Hat, he has already died. Okay, so this book is a little bit old and the language is a little bit tough to understand. But I will say, if you want to study, you can take any one of the book and you can study. Okay. And still, if you want to practice more questions, then I will say test series. Okay. So in test series, you will get ample amount of question, okay, from different sources as well as with different concepts. I myself is going to prepare the test series. Okay. So you will see a lot of question in your test series also. Okay. Any doubt regarding this? So you can ask, or you can just unmute yourself and say anything you guys want to ask. Fine. So now let us see the weightage of the subject. Okay. So for EC, each and every year you are going to see 8 to 9 marks question are asked from this topic, and the question, they are basically easy to moderate. Okay, easy to moderate. 8 to 9 marks question for electronics and communication. For electrical also it is the same, 8 to 10 marks you can say questions are asked. Each and every year you are going to find 3 to 4 questions have been asked from this topic, from this subject. And here also the questions are same. For IN you will find 10 marks always, not less than that. So here also easy to moderate. And believe me, the questions, if you study the concepts very well, it will be very, very simple to solve. Okay. Okay, fine. So now let me ask you, what do we mean by a linear circuit? What do we mean by a linear circuit? So what do you understand by the term linear? So what is meant by linear? Linear circuit, or just simple linear you can say?
Directly proportional.
Directly proportional.
Yes, output is directly proportional to input.
Okay. So that means you are saying y is equal to mx form.
Yeah.
Okay, fine. Okay. So as I asked you, what is your linear? Okay, linearity. So linearity basically means that if a circuit or an equation, if it follows your superposition theorem as well as homogeneity theorem or homogeneity property, then you are going to say what? That basically the equation or the circuit is linear. Or you can say what? That if your input, or sorry, if your output is directly proportional to input, then you are going to say what? That your circuit or the equation, it is your linear. Now what is the superposition or homogeneity? Can anyone tell me? Superposition? So if suppose we have a output and input relationship like this. Now this output input relationship, it can be something like this also, V of t is equal to R I of t. Okay. So we know basically this is Ohm's law. So we can have something like this, where y of t is your output, k is one constant, and x of t is your input. So by superposition theorem, we mean that if for input x1t, my output is y1t, which is equal to actually kx1t, and if for x2t, my output is y2t, which is equal to k x2t. Now if I add this two, basically, so y1t plus y2t is equal to k x1t plus k x2t. Now if suppose what I do, so here I have separately applied the input. Now if I simultaneously apply both the inputs, so that means x12t I have simultaneously applied, so the output I should get, it should be equal to the above. So this will be equal to what? K x1t plus x2t. So you can see what, that basically these two are the same. So this equation or input output relationship is following superposition theorem. Now what do we mean by homogeneity? So homogeneity is very, very simple. So we have taken y of t is equal to k x of t. So now what happens, look over here. So basically here a is also one constant. Okay, so that means what, over here what I am doing, if I multiply with a constant in your output, your input is also multiplied with a constant, or vice versa. If I do what, if I multiply the input with a constant, your output also gets multiplied with a constant. Okay, so here over here if I do ayt, so that will be equal to what, that is equal to ak x of t. And similarly if I multiply the input with a, so that will be what, a k xt. So this is also equal to this ayt. So this is what, this is homogeneous also. So basically this is the definition of linearity. Now in our circuit theory, whatever we study, we are going to always analyze the circuit in your linear range. Okay, so everything will be linear analysis over here. So our course, it has been divided in three parts: resistive circuit, second is time domain circuit, and third is your frequency domain circuit. Okay, sorry. So in resistive circuit, basically we are going to deal with memory less elements, or always your circuit will be in steady state. Okay, always in steady state. You will find that your circuit analysis is always taking place in your steady state. Now what do we mean by steady state? Steady state means once we have applied input to the circuit, we start the analysis of circuit at t tends to infinite. So if we have applied input at t equal to 0, then we start analyzing the circuit at t tends to infinite. So this is known as steady state analysis also, you can say. Next will be time domain circuit. So this is your transient analysis. So in transient analysis, basically, if we give input to the circuit at t equal to 0, we are going to analyze the circuit from your t equal to 0 till t equal to infinite. So this will be your transient analysis of the circuit. And the last will be your frequency domain circuit. So here we are going to apply AC input to your circuit. So we will basically have frequency components over here in this third topic. Okay. So any doubt? So our syllabus or our course is basically divided in this three parts. Anything you guys want to ask? Anyone? Anyone want to ask? Fine. So first, I told you guys, means while I was discussing over here, that electrical and electronics engineer, basically you guys are always dealing with either transfer of electrical energy or transmission of electrical energy. Okay, either transfer or transmission. So basically what are you transmitting or what are you transferring? Don't say electricity. Okay,
No, it's energy. Energy in one form to another form.
Yes, you are transferring energy from one form to another form, or you are transmitting that energy. But basically, what is that energy? See, like you have mechanical energy, you have electrical energy, okay, light energy. So basically, what is that energy and from where is it coming? See, everything that we deal, it is basically related to charge. Okay, charge. So flow of charge, it is known as what? Current. Okay, potential difference. So basically we have a difference in your what? Polarities, or you can say charge content. So that is your voltage. So flow of charge per unit time over a certain potential difference, it will be what? It will be your work done. And if we take that work done for a certain amount of time, if we want to basically summate the total amount of work done, we will be getting what? We will be getting the electrical energy. So everything, whether it be your electronics and communication or your electrical energy, you are just concerned with the either charge, flow of charge, transmission of charge, or transferring the charge from one form to another. Okay, so that discussion means the basics of those things we are going to start, means when we start our course. Today I am not going into your charge, voltage, power, energy. Today I will be just covering the basic thing that we already know from our previous whatever you have studied, like in your 11th class or 12th class, that we are going to see. Okay, so today we are going to basically see what? We are going to see Ohm's law. So what does Ohm's law state? Ohm's law states that your voltage across a resistance. So I'm not going into the definition of resistance and all those things. Okay, so if this is V and this is a I, basically these are constant voltage and constant current. So Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through the resistor. Okay, so this is stated by your Ohm's law. And if I want to remove this proportionality sign, so we replace it with the resistance of the resistor. So this is what is your Ohm's law. Now anyone want to say what are the constraint of Ohm's law? What is the constraint of Ohm's law? Pardon?
Temperature and pressure remaining constant.
Temperature and?
Pressure.
Yeah, you can say. Pressure we don't take into that much account. Okay, but Ohm's law, it is valid for your constant temperature. Now why is that? Because we know what? Resistance is a linear function, or you can even say we have actually linearized it across a non-linear function of temperature. Okay, so this is the relationship between your resistance and temperature. So you can see what? That Ohm's law is valid for constant temperature. So everywhere, wherever we are going to study, we are always going to consider that the circuit is always in your constant temperature. Now, according to Ohm's law, basically your current, conventional current, okay, sorry, conventional current I am saying, the passive current, it always flows from your higher potential to lower potential. Okay, so current, it always, according to passive convention, it always flows from higher potential to lower potential. So at that time, when our current follows your passive convention, so we simply write V is equal to IR. But if suppose across a resistor, . If current flows from lower potential to higher potential, then the voltage that is produced across the terminal, it is written as minus IR. Okay, this minus is basically indicating that current is flowing from lower potential side to higher potential side. Okay, so this is what is the basic of your Ohm's law. Okay, now if you want to know from where Ohm's law has actually come and all those things, then we have to go in the EMFT Maxwell's equation. We can derive it from there, but it is not required for our course over here. So next topic that we have, so today I will be actually dealing few questions with you guys. Okay, so I have few questions, so I want to cover those questions. So for those questions, actually I require all this topic, so that is why we are studying. So next topic that we are going to study is what it is known as your Kirchhoff's current law. Now what is this Kirchhoff's current law? So according to Kirchhoff's current law, basically it is based on the conservation of charge. So what is this conservation of charge? So conservation of charge states that charge, it cannot be created nor it can be destroyed. Only thing that we can do is transfer it from one place to another, or from one point, means from one form to another form. Okay, like in your tube light, you are basically converting what? You are converting your electrical energy into light energy. You are doing that. So according to this property, Kirchhoff current law, in any circuit, if we have a node, okay, if we have a node B, assume, so in this node, basically, if suppose in this node, this is your I1 current, this is your I2 current, I3 current, and I4 current. Basically, we have currents over here. So in this node, there are two conventions, or first let me state what is this Kirchhoff current law. So Kirchhoff current law states that across any node in a given network or in a given circuit, current will be always zero, or the summation of current will be always zero. Now why is that? Because in this node, okay, in this node, so if you have a circuit that looks something like this, okay, so this is one node. Okay, so in the node does not have the capability of storing any charge. Okay, so that is why from conservation of charge, the number of incoming charge is actually equal to your outgoing charge, or flow of charge is actually known as your current. So that is why we are telling what, that basically the summation of current over a node, it is always zero. Okay, so over here we have few convention. So I always consider incoming current in a node, incoming current is always negative, and outgoing current from a node, it is positive. Okay, outgoing current from a node, it is positive. So according to that, now you can even take the reverse convention, but usually when I solve question, I am always going to follow this convention. It is not like that if you do consider incoming current as positive and outgoing current as negative, you won't be getting the correct answer. You will be getting the correct answer, but this is the standard convention that is followed. Okay, so according to this, you can see incoming current is negative, so minus I1. I2 is also incoming to node B, minus I2. I4 is outgoing, I3 is outgoing. So the summation of total current across a node is always equal to zero, or in short, you can write IK is equal to zero, where K varies from 1 to 4 over here. So if you have like n elements over here, so you can even generalize it like Ik K equal to from 1 to n, it is equal to 0. Okay, So this is what is your Kirchhoff current law. If you want to ask something, you can ask. Okay, so it is based on the conservation of charge. Anything you guys want to ask? Fine. So next we have is what? We have your Kirchhoff voltage law. So can anyone tell me on which property is your Kirchhoff voltage law based? Kirchhoff voltage law. So later on we are also going to see that this Kirchhoff current law as well as your Ohms law, KCL plus Ohms law will give us nodal analysis. Okay, it will give us nodal analysis. But at this point, we are not going to study that. Later on, we are going to see. So Kirchhoff voltage law, it is actually based on the conservation of energy. So conservation of energy states what? That energy can neither be created nor it can be destroyed. Basically, energy can be transferred from one form to another form. So basically, it is based on that property only. So according to Kirchhoff voltage law, the total voltage across your closed loop is always zero. Okay, it is always equal to zero. Now why is that? So we are going to draw one circuit over here, very simple circuit. So according to KVL, if we go across a loop, the total voltage across the loop is equal to zero. So if I start writing KVL from this point, so remember one thing, KVL should start and terminate on same point. Okay, later on when we study analog electronics, at that time you are going to see that KVL starts from ground and it will terminate to ground terminal. But in our network theory, we are not going to require that concept. Okay, so KVL should always start and terminate on the same point. So if I start from here, so and if I go in this direction, clockwise direction, so what you see, if I want to go from here, the first sign that I encounter is negative. So I am going to write minus V because the summation of total voltage is always zero. Now over here you can see that this is plus V1. So I am going to write plus V1. Over here we have plus V2. And when we come over here, we encounter plus V3. So this is equal to 0. Or you can write over here what? That basically V is equal to V1 plus V2 plus V3. Now why actually I told that KVL is based on your energy conservation? If you remember this, voltage is dW by dQ. Okay, voltage is dW by dQ. So if you write over here, so this is equal to what? dW is what? It is your rate of change of work to, means what is the definition of voltage? Definition of voltage, rate of change of work done to move a unit charge from a point to another point. It is known as the voltage difference between those 2 points. Okay. So over here, if I replace V, so I am going to write dW by dQ is equal to dW1 by dQ plus dW2 by dQ plus dW3 by dQ. Why dQ? Because you can see the current is same over here. Okay, current is same. So that is why you can write what? W is equal to W1 plus W2 plus W3. So basically your KVL is based on the conservation of your energy. Okay, is that clear? So later on we are going to study that combination of KVL plus Ohm's law is going to give us what? It is going to give us your mesh analysis. Okay, it is going to give us mesh analysis. So what I told, KCL plus Ohm's law, it gives us nodal analysis, and KVL plus Ohm's law, it gives us mesh analysis. Now let us study the concept of power absorbed and power delivered in an element. Okay, so what do we mean by basically power delivered and power absorbed? Okay, so if suppose, so what is power? Anyone want to say? What is power? What is power? Rate of change of energy with respect to time is known as your power. Okay, so I can do what? dW by dQ into, means dQ by dt I can do. Okay, so I have multiplied and divided with dQ. So this is dW by dQ, it is V, and rate of change of charge across a time, it is known as your current. Okay, rate of flow of charge over a cross section in a time is known as current. So basically, electrical power is what? It is the product of voltage across the element or the cross section multiplied with the current. Okay. So if we have an element X whose terminal voltage is V, and if current I is flowing inside your terminal, positive terminal of X, we basically say that power absorbed is equal to what? It is equal to V dot I. Okay, so whenever current enters through the positive terminal of an element, we say power absorbed. Now why we are basically saying power absorbed? So if suppose this element X is something like this, so this is your element X where we have resistance R, this is your V, and this is your I. So now why I am basically telling that power is being absorbed over here, you can see current is flowing from positive terminal to negative terminal. So whenever current is flowing from positive terminal to negative terminal, so power is getting absorbed. Okay, power is getting absorbed. Now I will give you a very simple example. Okay, like if you have water, okay, so you have water over here, and this water is flowing over here. So basically you can see the potential energy of this water is getting transferred into kinetic energy, and we don't need to do any work over here. Water will be flowing on its own because it is the nature of the water or the nature of gravity that any object at a higher height, it will be flowing towards your, it will be rolling down towards your lower height. Okay, similarly in current also, current always flows from higher potential to lower terminal, means lower potential, without any external support. It can flow. But when I want to, if suppose this is the positive terminal, this is the negative terminal, and if current is flowing like this. So here you can see current is flowing from lower potential to higher potential. So if suppose in this overhead tank, if I have to fill water from this reservoir, okay, so this is reservoir. So by default, this water cannot flow to a higher height. What I require? I require a pump over here. So this pump is actually going to what? It is going to deliver water at a higher height. So whenever your current flows from your lower potential to higher potential, at that time, basically power needs to be delivered. So if this element X was something like this, and if current was coming out from the positive terminal, you are going to say what? That power is being delivered. So this concept, basically, it is like this. If current enters the positive terminal of element, this implies power will be absorbed. And if current exits the positive terminal of element, this implies power is delivered. Tell me if this concept is clear or not. If you have anything you want to ask, you can ask me. Tell me. Up to this point, is everything clear? Anything? Okay. So now let me take one more example and we will understand one more concept over here. See, there is one more very important concept that we need to see. So if we have, suppose we have like a 2 ohm, or it's okay, I will just write R over here. And this voltage is like 4 volt and current is 2 ampere. Okay. So now if I ask you, what is the power over here? Power over here. So you are going to say, sir, that power is being absorbed over here. And the magnitude of the power that is being absorbed, you are going to say what? That it is going to be 4 into 2, 8 watt. Okay, you are going to write like this. But the same circuit, I can even write it like this. See, basically 2 ampere current was flowing from higher potential to lower potential. So I can do what? I can reverse the direction of current along with reversing the means polarity of the current also. See if this is correct or not. What I have done, basically I have reversed the direction of current, and here it was plus 2 ampere. I have done what? I have written minus 2 ampere. So this is also the same. Okay, this is also the same circuit only, just a different representation I have done. So here if I ask you what is the power, so you are going to say, sir, as current is coming out from the positive terminal, so that means power is being delivered. So what is the power delivered over here? So it is 4 into minus 2, so that is equal to minus 8 watt. Okay, it is equal to minus 8 watt. So that means what? In a circuit element, the power absorbed by element plus power delivered by an element, it will be always equal to 0. No matter what is the element, it doesn't matter. If power absorbed by the element is P, okay, so the power delivered by means, if suppose if we have an element and I tell you that that element is absorbing x power, sorry, x watt. So now if someone asks you what is this element delivering how much power, so you are going to say power delivered will be equal to minus x watt. Why? Because we have this property. So tell me if you have understood this or not. If you have understood this or not, tell me yes or no. So this is very, very important. Okay, very important. Now let me ask you some questions. Okay, in all of this, you are going to tell me what is the power absorbed. In all the four elements, you are going to tell me what is the power absorbed. So very quickly tell me. So this is figure A, this is figure B, this is figure C, and figure D. So anyone want to say something?
Minus 4 watt for figure A.
Minus 4 watt you are saying. So I have asked power absorbed, okay? Remember. Okay. For this one,
For this one,
pardon?
this is 4 watt.
4 watt. What about this one?
Minus 6 watt.
This one?
So it's again minus 6 watt.
Okay, minus 6 watt. Okay. So you have given me this answer. Now look, if you are not able to guess or if you are not able to get the answer, look over here. So I told what? You need to find power absorbed. Power absorbed. So the concept of power absorbed is that current should always enter where? It should enter the positive terminal. So here you can see basically current is going away or it is exiting the positive terminal. So that means over here we have the concept of power delivered. So power delivered over here is how much? It is 2 into 2, that is equal to 4 watt. Now if power delivered is 4 watt, so from this theorem, what I can write, if power delivered is 4 watt, that means power absorbed is equal to minus 4 watt. So this is correct, minus 4 watt. Now look over here. I have once again said power absorbed. So if power absorbed, that means what? Current should be entering through the positive terminal. And here you can see that basically it is in the style of power absorbed only. So power absorbed over here is equal to what? 2 into minus 2. So that is minus 4 watt. Now basically minus 4 watt. If power absorbed is minus 4 watt, now this minus is actually suggesting that power delivered in this particular case will be 4 watt. That means basically this element is delivering how much power? It is delivering 4 watt. So this also, this you have said minus 4 watt. So this is means plus 4 watt you have said. So this is wrong. Minus 4 watt is correct, because I have asked in each of the question what is power absorbed. You have said me this is actually power delivered. Okay, so minus 4 watt is correct. Now look over here. Once again I have asked power absorbed. So this is actually what you can see, current is exiting the positive terminal. So here basically the style followed is that of power delivered. Now how much is power delivered? So you can see 2 volt into 3 ampere, so that is 6 watt. So if power delivered is 6 watt, that means power absorbed will be equal to what? It will be equal to minus 6 watt. So this is correct. And in the last question, once again you can see current is entering through the positive terminal. So that means this is your what? This is written in the style of power absorbed. So power absorbed is equal to 3 ampere into minus 2 volt. So that is equal to what? Minus 6 watt. Now if power absorbed is minus 6 watt, that means power delivered is equal to what? It will be equal to plus 6 watt. So this answer also you have told me correctly. Okay. Minus 4 watt for the second. Yes, minus 4 watt for the second, Shweta. Correct. Okay. Minus 4 watt. Very good. Fine. So let me ask you one more example, means few more examples. Very quickly, tell me what will be the power delivered over here in the 4 cases. What will be power delivered over here? So the style of power delivered is basically what? Current exits positive terminal. Okay, remember this. So in the first case, so look over here. I will ask means all of you whether you have written the correct answer or not. So look over here. Here you can see this is a current source. So 2 ampere current is going out from the positive terminal. Okay. So that means this is already in your style of power delivered. So power delivered is equal to what? It is equal to 5 volt into 2 ampere. So that is 10 watt. So if power delivered is 10 watt, power absorbed is equal to what? It is equal to minus 10 watt. But here I have asked in all the 4 questions what is power delivered. So 10 watt will be your answer. Now look for B. If you look over here, so minus 2 ampere current is going out from this positive terminal. That means once again over here also it is written in the style of power delivered. So power delivered is equal to what? It is equal to minus 5 into minus 2. So that is equal to plus 10 watt. So these two circuit are the same. Okay, it is the same over here. Sorry, yeah, this is the same. Yes. So now look over here, means power delivered here also it is equal to 10 watts. So this is the answer for C. Look, so over here you can see 2 ampere current, it is basically entering the positive terminal. Okay, 2 ampere current is entering the positive terminal. That means over here we can direct, this is actually following the style of power absorbed. So what is power absorbed over here? So power absorbed is equal to 2 ampere into 5 volt. So that is equal to 10 watt. So if power absorbed is 10 watts, so power delivered will be equal to minus 10 watt. So minus 10 watt is the answer for C. And for D, if you see, so you can once again see that minus 2 ampere is entering the positive terminal. That means what? Here also it is written in the style of power absorbed. So power absorbed is how much? It is equal to minus 2 ampere into minus 5 volts. So that is equal to plus 10 watt. So if power absorbed is plus 10 watt, that means power delivered will be equal to what? It will be equal to minus 10 watt. So minus 10 is the correct answer for option D. How many of you got all four correct? How many of you got all four correct? No one? All three means three?
Two are correct.
Two
Mine
got.
is two correct.
Two are
So,
correct.
in which questions were you guys confused? Tell me that.
B and C.
B and D.
B and
C.
Okay, B and C. So these were quite simple. See, whatever is given in the question, you take that. You just see the direction of current, whether it is exiting the positive terminal or entering the positive terminal. If it is exiting through the positive terminal, by default, you will get power delivered. If it is entering through the positive terminal, by default, you will be getting power absorbed. Once you get power delivered or power absorbed, the opposite is going to be the counterpart of that. If power is getting absorbed, so negative, if you add, you will be getting power delivered. And if you have your negative power delivered, so the opposite of that means positive, it will be power absorbed. Now is the concept clear, everyone? Please tell me.
Yes, sir.
If any one of you have any doubt, so Pallavi, Sriya, Swagatika, Shweta, if any one of you have any doubt, you can ask.
No, sir. Clear.
No, sir, we are good.
Okay, so if it is clear now, let us solve question. So solve this question. This is your GATE 2014 question. So take 1 minute and solve this problem. Answers, anyone? See, basically you need to apply KCL as well as your power delivered and power absorbed. So what is the question? See, whenever you are attempting questions of circuit theory, you can solve the question using different methods, but you need to stick to one method and get answer out of it. Okay, so later on when we solve problem of two-port network, you will be seeing that if you take different approaches, it will get quite lengthy. So better to stick with just one approach and solve with that. So look over here, what is the question? The three circuit elements shown in the figure are part of an electric circuit. So this part, it is actually a part of an electric circuit. We don't know what else is connected over here. Just this is one part of electric circuit, that much we know. The total power absorbed by the three circuit element in watt. You should note this, whether they have asked in watt, kilowatt. Okay, so that needs to be noted. So total power absorbed they are asking. Okay, so here you can see, we know in a battery, this is your positive terminal, this is your negative terminal. So this we know. So over here, this is positive, this is negative, this is positive, this is negative. So if this is your source 1, this 100 volt and 10 ampere, I am writing this as source 1, this 15 volt is source 2, and this 80 volt is source 3. So you can see what, that this source 1 is by default written in your convention of power absorbed. Why? Because through the positive terminal, 10 ampere is getting inside, okay, or it is entering through the positive terminal. So power absorbed by source 1, it is equal to what? Because directly it is written in the convention of absorbed power, so that is why I am writing. So it is equal to 100 into 10. Yeah, so Shriya has written all the answer, very good. So let me solve. So that will be equal to 1000 watt. Now look for source 3. So source 3, you can see 8 ampere current is exiting through the positive terminal. That means by default for source 3, we will be getting power delivered. So that is equal to 80 into 8. So that is equal to 640 watt is being delivered. If 640 watt is being delivered, so that means absorbed power will be equal to what? It will be equal to minus 640 watt. Okay. Now look for source 2. So we don't know what is the current. But if we apply, sorry, just give me a second. So if you look over here at this node, if you apply KCL, so you can see 10 ampere current is entering. So let me assume that basically X ampere current is entering through this terminal. Okay. Or you can means you guys know KCL, so I cannot do like that. So if 10 ampere is entering from this, 8 ampere is exiting. So that means 2 ampere should come out from here. Okay. So if that is the case, once again, you can see this is positive terminal, negative. So for source 2 also, by default, power delivered is being written. So power delivered by 2 is equal to what? It is equal to 15 into 2. So that is equal to 30 watt. So power absorbed is equal to what? It is equal to minus 30 watt. So now over here, total power absorbed. So total power is equal to PABS1 plus PABS2 plus PABS3. Okay, so this is equal to 640, sorry, plus 1000 minus 640 minus 330, sorry, 30. So that is equal to what? This is equal to 670. So that will be 330 watt. Okay, so 330 watt is the answer. But if in this question only they had asked what is the total power delivered, total power delivered will be what? It will be equal to minus 330 watt. Okay, is that clear? So very good, Shweta, Shriya, you guys have got the correct answer. Very good. So this is the next question. This is one very good question. Solve this very quickly. A. Okay. So look over here. A. So what is given in the interconnection of ideal sources shown in below figure? It is known that 60 volt source is absorbing power. So 60 volt source is absorbing power. Okay. Which of the following can be the value of the current source I? So while I was preparing back in 2013, I couldn't solve this question for like one day. Okay, I was sitting and I was thinking, what is happening over here? I couldn't solve this question. Okay, so look, basically what is asked, that what can be the following value of this current source I. So it is given that 60-volt source is absorbing power. Okay, 60-volt source is absorbing power. That means if I assume this to be as I1 current, so as it is said, if I assume that a current I is flowing in this 60 volt, as it is said that the 60 volt is absorbing power, so the direction of this current should be entering through the positive terminal. So this is I1. Now if I apply nodal analysis at this point, at this node, so what you can see, incoming current is minus, means I is incoming current, so I have written minus I1 is also incoming, so minus I1. 12 is outgoing current, so plus 12 equal to 0. I need to find the value of I. So I is equal to 12 minus I1. Now it is already said that 60 volt is absorbing power. That means I1 is greater than 0. Because if I1 is equal to 0, then no power will be absorbed. So that means I1 is greater than 0. If I1 is greater than 0, that means I should be less than equal to 12. So in all the four options, you can see only option A is I less than 12. So that means option A is your correct. Okay. So this is your trick kind of question. So it has been asked over here. So this question, so this two question, you can note it as your homework. This question and this question. Okay, so here we have one concept. Let me tell you that if suppose I have two network N1 and N2, okay, N1 and N2. If suppose from N1 we have a current going from N1 to N2, it is I1. So for this circuit to get completed, so can you just unmute yours, means mute yourself, Swagitika? Yes. So if suppose you have from N1 to N2, if I1 current is going, so that means from N2 to N1 also you will have I1 current, or else the circuit won't be completed. If suppose there is no connection over here, so this I1 current should always be equal to 0, because there will be no current flowing. So there should be always the closed path. If there is a closed path, and if from N1 to N2 I1 current is flowing, then from N2 to N1 I1 current is flowing. So this is the concept in this question. Based on this concept, this question is also there, and this question also. So you can see this question has been asked in 2015, this is in 2012, and this is in 1993. So questions exactly it is not going to be repeated, but the concept is going to be repeated. So this questions, this question, this question, and this question, it is your homework question. So you can take screenshot either, or I will be sending you the PDF on our group, so you can even download it from there. Okay, so if you have joined our WhatsApp group, so you will get the PDF from there. You can solve these questions. Okay, so I will be ending the session over here. If you guys have any doubt or any queries, you can ask me. So any doubt or any queries? Okay. So Shweta, Swagitika, Shriya, any doubts you guys have?
No, sir.
Okay, fine. So I hope you guys have enjoyed the session. Okay, and I hope to see you in our classes also. And I will be sending the slide in our group. You can download it from there and you can solve the questions. Okay. So, okay, then good night. If you guys have any queries, you can even ask in our WhatsApp group also. You can contact either me or Dinesh sir regarding your doubts, and we will take care of those things. Okay. So Dinesh sir, are you present? Okay, so Dinesh sir, he has left. Okay then guys, good night everyone. So I am ending this session.
Thank you, sir.